The History of Atoms by Maile Risch. An atom is the smallest particle of an element that retains its identity in a chemical reaction. But who are the scientists who discovered the atom? Democritus had a theory that all matter consists of invisible particles called atoms, that atoms are indestructible, solid but invisible, and homogeneous. Lastly, he conferred that atoms differ in size, shape, mass, position, and arrangement. He claimed that solids are made of small, pointy atoms. Liquids are made of large, round atoms, and oils are made of very fine, small atoms that can easily slip past each other. In 400 BC, Democritus created the first model of the atom. There were no electrons, protons, or neutrons at the time, but his model helped other scientists understand and continue further research about the atom. Aristotle was born in 384 BC. He was one to not believe in the atomic theory. He thought everything was made of the four elements of matter: earth, fire, water, and air. He was later proven wrong. Antony Lavoisier proposed the law of conservation of mass, which represents the beginning of modern chemistry. The law states that the sum of the weight of two chemical substances, when combined, is equal to the weight of the newly formed compound. He claims that mass can't be changed and stays the same universally. He disproved the old theory and paved the way for the modern theory of an atom. He determined this by the process of oxidizing mercury oxide. When burning mercury oxide, it absorbs oxygen from the air, thus meaning it subtracts the mass from the air and adds it to itself. He concluded with a powder with a bigger volume, weight, and mass. However, the mass stood the same universally. John Dalton proposed the law of multiple proportions, which he stated all matter is made of atoms. All atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms, and a chemical reaction is a rearrangement of atoms. His law led directly to the proposal of the atomic theory in 1803. J.J. Thomson identified the negatively charged electron in the cathode ray tube in 1897. He tested experiments that passed electric current through gases at low pressure in glass tubes. The seals were electrodes connected to electricity. One was positively charged, called the anode, and the other was negatively charged, called the cathode. The result was a glowing beam, the cathode ray, which traveled from cathode to anode. Thomson also created the plum pudding model of the atom. It was a positively composed atom. The smaller electrons are dispersed throughout the positive mass to maintain charge neutrally. He explained some electrical properties but failed to recognize the positive charges. He was therefore proven wrong by Rutherford on his plum pudding model and his cathode ray. Robert Millikan determined the unit charge of the electron in 1909 with his oil drop experiment, thus allowing for the calculation of the mass for the electron in positively charged atoms. He determined this by his oil drop experiment. He put a charge on a tiny drop of oil and measured how strong an applied electric field had to be in order to stop oil from falling. Because he knew the mass of oil, he could calculate the force of gravity on the drop and electric charge that drop must have. By differing the charge on different drops, he noticed that the charge was always a multiple of negative 1.6 times 10 to the negative 19th power, the charge on a single electron. Ernest Rutherford proposed the nuclear atom as a result of the gold foil experiment in 1911. He fired the beam of alpha particles throughout the piece of gold foil and observed the location at which the particles landed on the screen. If the plum pudding model was correct, each particle should have gone directly through the foil, meaning that an atom was a vast amount of empty space and could easily be passed through by any particle. However, a small handful of particles were deflected slightly from the straight path about 1 or 2 degrees. Even bigger when 1 in 20,000 particles deflected approximately 90 degrees or more from the parent beam. He came to 2 conclusions. One was that the atom was more than just empty space and scattered electrons. And 2, an atom must have a positively charged center that contains most of its mass, the nucleus, which he determined. He proved J.J. Thomson wrong. Since only a small number of alpha particles veered slightly when passed through the foil, and since even fewer bounced back at this experiment, Rutherford reasoned that this positively charged center was relatively small in reference to the total size of an atom, leaving J.J. Thomson somewhat correct. He proposed the third atomic particle, the neutron, who James Chadwick had later discovered in 1932. In 1924, Louis de Broglie discovered the wave nature of electrons and suggested that all matter have wave properties. He came up with the pilot wave theory, that particles of matter also had wavelengths and could behave as waves, just as photons did. The photon, a particle of energy, had a wavelength associated with it. Therefore, particles of matter, such as electrons, should have wavelengths. James Chadwick established that the atomic number is determined by the number of protons in an atom. Rutherford had noticed that the atomic number, the number of protons, was less than an atomic mass. Helium has an atomic mass of 4, but an atomic number of 2. Since electrons have almost no mass, it seemed that something besides the protons in the nucleus were adding to the mass. He put out an idea that there could be a particle with no charge but a mass, which was later called the neutron. James Chadwick used different elements as radiation targets by comparing the energies of particles ejected from various targets. He was able to prove that the radiation causing the ejected particles was much more energy than could be accounted for by photons. When a particle having the same mass as a photon hit beryllium with alpha particles, a carbon-12 nucleus and the emission of a neutron was formed. He determined that the neutron did exist and that its mass was about 0.1% more than a proton's.